Hello and welcome to episode 2 of Math Hell, where we'll be going over a problem from section 7.6, which is number 3 in the book, but number 1 in your assignment. The problem in the book asks you for this definite integral and tells you that you will have the exciting opportunity to use the integral tables, everyone's favorite part of calculus. So they tell you it's entry 39, which I have carefully and with great forethought recorded here. And I totally meant to have to write it out on 2 lines because it's just that much excitement packed into one single formula. Now, they do tell you to use number 39, but I hope that it would be clear to you that that's what you'd be using. If you take a look at the integral, the 15 in front, of course, we could pull outside, so that's not going to make a big difference. What's really interesting here is we've got a square root or a radical, which we have here. We've got our x squared coming first. It's 4x squared, but again, constants less important than the variables here. So 4x squared is going to translate to our u squared in the formula. We've got a minus in the middle, and then we've got 3, which corresponds with a squared. Now, you don't have to worry about what a itself is, which is really nice about this formula. It turns out if you look at the whole formula, we never actually use a by itself. A stays squared in all the settings. So we don't have to worry about, whether or not a is a perfect, whether a squared is actually a nice number to take the square root of, plus or minus. So to get started, what I'm going to do is, as I mentioned before, I'm going to go ahead and take the 15, pull it right out. That 15 doesn't need to be there. And then I'm going to start connecting the dots. The u squared in the formula is going to be the 4x squared in the problem. So I go from u squared to 4x squared, which tells me that u must then be 2x. Oh, you can't see that. Let me move it up. Sorry about that. Here come the eyeballs. There we go. U squared is 4x squared, so u equals 2x, so du equals 2 dx, so du over 2 is dx. So this is just like a regular old u substitution. A squared equals 3, and I went ahead and wrote that a could be plus or minus radical 3 depending on our restrictions. However, we're not going to be using that. We're only going to be using a squared, so that part I got carried away in the moment. You did not have to do that. Another thing I'm going to do, because I love you, is I'm going to go ahead and convert my limits. You know how I prefer to keep limits unconverted, but I'm going to go ahead and convert these limits. So I'm going to go from x equals 1, which means u, which is 2x, is 2, and x equals 2, which says u is 2 times 2, so that's 4. So my new limits with my new substitution, where I've got u squared equals 4x squared, a squared equals 3. I've got limits, I've got this wonderful thing, and remember I had this du over 2. So thing to keep in mind when you use the integral tables is you're actually, once we convert it into u form, it will fit the integral in that particular line. In this case, it's entry 39. It will fit it perfectly with the exception of there'll be a different constant out in front, and there'll be interesting new limits there. But inside the integral, we should fit exactly with what the formula is. Through the magic of television, I have a second page all ready for you. Look at that. Ooh, so fancy. This is, I think, if anything was going to be worth a field medal, this right here. This is dedication to math right here. Okay, so what did I do? Ooh, it's going to be helpful if you see the previous page. So here's the previous page. We had our 15 halves out in front, which I preserved there. Then I had this radical u squared minus a squared, and then I went ahead and I copied down the hideous formula right there. And that is a thing of beauty and horror at the same time. Then I'm going to, since this is a definite integral, I have to evaluate this between 2 and 4, between 4 and 2, depending on your perspective. So, what did I do? Well, here I went ahead in the first line and I said, well, since a squared is 3, I plugged in the 3's. So I did this very slowly. You don't have to take as many lines. Next up, I don't have to convert u back to x unless I left the limits in x. Since these limits are now in u, I just evaluate in u. So u squared is 16, u is 4, then u squared is 16, and I subtract evaluating it at 2. I've got 2 over 2, since u is 2, 4 minus 3, and then in here u is 2, and u squared is 4. And then at this point, it's more accounting than mathematics, because we're just going to be evaluating these, well, values. I simplified 4 over 2 to be 2. 16 minus 3 is 13. There's not really much I can do with radical 13, so I leave it there. Square root of 4 minus 3, or radical 4 minus 3 is 1. 2 over 2 is 1. 1 times 1 is 1. 3 halves, and then this guy, the only thing I can simplify is I've got 2 plus radical 4 minus 3, that's 1. Then I went ahead and simplified. I added some things together. You'll notice the 2 plus 1 became 3 down here. And in my final form, I multiplied through by the 15 halves, and then I also reduced or simplified this. We don't need to keep the absolute value in the natural log. Since we know this value is positive, we can just put it in parentheses. And in fact, I think in the book they dropped the parentheses on the 3. But that will be your answer. Woohoo! I hope that sucks a little bit less than it did.